variables. Remember that quantitative variables are measured in numerical units, units we can mark on an axis and do calculations with. We're going to make a scatter plot to show the relationship of powerboats to manatee deaths. But first, let's take a look at the situation in Florida, where manatees and powerboats share the sea.
These strange creatures are manatees, a species of marine mammal found along the coasts of Florida. Manatees are slow-moving, gentle, unafraid, and extremely curious, endearing traits, but ones which are posing a threat to manatee survival.
This manatee here is using a line that we call the dental flossing line for manatees. They like to chew on them. If you're not real careful when you start your motor, you could inadvertently end up injuring one of these beautiful animals.
In fact, almost every manatee in these waters displays on its body evidence of an encounter with a boat propeller. And these manatees are the lucky ones. Many of these collisions are fatal.
This one with...
These scars are so prevalent and so distinctive that they allow biologists to identify and count the animals.
2 little prop scars on it.
Manatees depend on warm water for survival, so they seek out places like this power plant where warmed wastewater provides a perfect winter habitat. Because so many manatees migrate to just a few locations each winter in search of warm water, the state has set up manatee sanctuaries where speed limits are strictly enforced.
Skipper, take your boat out of gear. I'll be coming on your port side. Y'all gonna have to be more conscientious of this manatee zone. That's too fast in there. I know you don't want to hit one of them. I'm sure you don't want to do that, all right? Watch your water. A good way to tell is you look at the back of your boat. If you're peeling off that white water off the back of the boat, it's too fast.
Even though these sanctuaries provide some protection for manatees, the task is getting harder. Because as the pace of development along Florida's waterways is increasing, so is the number of manatee deaths caused by humans.
The factors in Florida that are causing these deaths are on the increase, and the factors are related to development, increased numbers of people using the water. The problems the animals face are directly related to the growth of the state, and we have to accommodate the animals as we accommodate the human growth. And they're extremely adaptable animals. They're tough, they're resilient. If we just give them a chance, I think we can keep them around.
We're going to use information from biologists to make a scatter plot of the relationship between the number of powerboats and the number of manatees killed. We put the number of Florida motorboat registrations on the horizontal, the x-axis. They're measured in hundreds of thousands. The number of manatee deaths caused by boat are on the vertical, the y-axis. This isn't an arbitrary arrangement. We're speculating that manatee deaths are a response to the number of motorboats. We call motorboat registrations, therefore, the explanatory variable, and manatee deaths the response variable. The response variable is an outcome, and it's plotted on the vertical axis. The explanatory variable is something that helps explain that outcome, and it's plotted on the horizontal axis. With our axes labeled, we can start to plot the information from 1977 to 1987. Each point represents a single year's information on these two variables. In 1977, for instance, there were about 447,000 motorboats registered and 13 manatee deaths. In 1978, 460,000 boat registrations and 21 deaths. In 1979, 481,000 boats and 24 deaths, and so on. In statistical terms, each point, each year, is a single case. We can interpret scatter plots using the same strategy we've used for other types of graphs. First, look at the big picture. Then look for deviations from that overall pattern. Here, the scatter plot shows a clear trend. It rises to the right, meaning that as one variable, motorboats, increases, the other, manatee deaths, also increases. This pattern is called a positive association. If one variable increased as the other decreased, the pattern of dots would fall to the right, and we'd have a negative association. Be careful not to overinterpret associations. changes in one variable don't necessarily cause changes in the other.